after del, what is this? After coming to know about del operator, what is this gradient of a scalar? First of all, why of a scalar? Means, is there any case like gradient of a vector? No, the gradient will be operated only on scalar. That first you remember. Like I have mentioned very clearly about this gradient, curl and all in the lecture of mathematics very nicely. So what is the differential element v, that is dv? The dv will be given as like this: dou v by dou x ax plus dou v by dou y ay plus dou v by dou z az, dot product with dx ax plus dy ay plus dz az. Right, out of these two vectors which are giving dv, the first vector is known as gradient, remember. So the gradient is going to be performed on a scalar, but that gradient is the result is a vector. Are you getting? That is this first vector. So there I have mentioned with an arrow symbol. That is nothing but gradient of v, where the v is the scalar. Okay, and the magnitude of that gradient of scalar is known as maximum rate of change in v per unit distance. Okay, because you are differentiating it, partial differentiation with respect to some length or distance. That's why it is per unit distance. And it also represents both the magnitude and the direction of the maximum space rate of increase of v, because as the result is a vector, it is going to have both magnitude and direction, and I am saying which direction it is going to represent. Okay, so that is important, and these are the properties of gradient. That is gradient of u plus v is nothing but gradient of u plus gradient of v. Similarly for product you are having one formula, and for what is that division you have one formula, and for power n also you are having the formula. All these are like you can easily get them if you derive. Okay, you just go through them. And the del v, that is the gradient of a scalar at any point, is perpendicular to the constant v surface that passes through that particular point. Means at any point it will be perpendicular to the constant surface, which is nothing but that v which is passing through that particular point. Okay, that's it. What is meant by directional derivative in general? So it is an important concept, because in exams they will ask you find out the directional derivative. Like it is universal. Mathematics itself is universal. You can apply that in any subject. So it is not like mathematics, fields or anything. Okay, this is a tool which will be used for solving some problem. So this directional derivative of a unit vector a bar is nothing but gradient of scalar dot product with unit vector. That is nothing but the projection of gradient of v in the direction of unit vector a bar. Okay, and the directional derivative is nothing but rate of change of that particular scalar surface v. Okay, right, and means directional derivative means dot product with some particular unit vector, and in the exam they will give you the unit vector, right? If you solve the problems you will understand. Okay, then a bar equals to del v, that means the resultant vector a bar, if the resultant of a gradient of a scalar v is a bar, then it will be a bar equals to del v. Then in that case that scalar v is said to be scalar potential of a bar, like just some term. That why that is potential you will come to know while we are discussing about the concept of potential. Okay, as of now you remember that the result or the gradient of a scalar will be known as scalar potential. Okay, that's it. Thank you.